speaking on the question that I think is actually the best named title of ShmooCon. Who's got time for that? Looking at advisories and blogs for threat data.
Well, thanks for that introduction and for the shout out to the title. Everyone, I'm Shimon.
I'm Elvis Hoover.
And we are both security researchers working for Accenture Technology Labs. It's the R&D arm of Accenture, if you've heard of the large consulting firm. And who are we? So both of us are security researchers. We also have a research team that's focused on natural language processing. The core mission of Accenture Technology Labs as a whole is to address essentially challenging problems within certain domains. Elvis and I focus on security, and because of the wealth of expertise there is, we also do a lot of cross-domain research. So we're essentially working on different research projects and seeing if we can address any real-world problems. So one of the things that we have been focused on over the last few months is the notion of how do you operationalize on threat data. And I will not use the word threat intelligence, because one thing I want to stay away from is at least giving any false notion that we are trying to tackle the large problem of threat intelligence. We're still focused on threat data. And what we want to talk about is the techniques that we are researching to bring to bear upon from the NLP side, the natural language processing side, to threat data extraction within the security domain. Right, so I just want to create a frame of reference around the problems that we want to talk about. And when we talk about the challenge space, again, focused on threat data itself, right? When we start talking about threat intelligence, there are a lot of connotations. Not talking about advisories, we're not talking about indicators, but the actual data that, how many of you are threat analysts in the room here or spend a lot of time looking at threat data, right? It's you folks who are turning the data into intelligence. What we really want to focus on here is how do we put the right kind of tools that can make your life easier, make you more efficient. The human is not going out of the loop. The human will stay in the loop no matter what we say. So let's try and address challenges that humans are facing today. What are the kind of desired functionalities, right, as we started looking at the challenge space? There are some low-hanging fruits, and there are some pie-in-the-sky, blue-sky ideas. What is the entire spectrum of those ideas, and which are the ones that we picked that we felt were at least addressable in the near-term range? The framework behind how we are cross-pollinating ideas from natural language processing and information extraction into the security domain itself. I particularly haven't come across too much research within the space, and I'll be interested in hearing more about from at the end if there are any ideas and if you've seen other research work that's similar. The methodology and results. So this is an experimental framework. Natural language processing, underlying that is machine learning. It is a continuous iterative process in terms of improving, leveraging the human intelligence and human expertise to make the machine part more intelligent, right? So it is an iterative process. We are going through this in terms of, it is a work in progress, right? So the results that you see are real results, and some of them good, some of them not so hot. So we'll be pointing out the kind of challenges that we are seeing. Don't want to just talk about this. This is not supposed to be a pedantic presentation. So what is it that we have put together that really brings this idea to life? And what do we see going forward in terms of how do you make these improvements? And again, would love to hear feedback and opinions around what can be done based on the kind of things that you're seeing in your day-to-day lives. All right. So as you read through this, I'm not going to drain the slide. This should resonate with those of you who do spend even a little bit of time trying to study or trying to look through threat data on a day-to-day basis. To me, it's the 80-20 problem of human analysis. Instead of spending 20% of your effort to get 80% of the results, it's kind of the other way around. And correct me if I'm wrong. Right? How many of you spend a lot of time pre-processing the advisories, the blogs, the data, to actually put it into some kind of a usable format? those are essentially pre-processing techniques that can be easily replicated using computing technology, right? So what we want to try and do in terms of addressing the core issue of trying to leverage humans to do things that they are actually good at and not wasting their time on techniques or processes that can be actually automated. Humans don't scale, right? There are only so many experts and analysts that we have. Some of the largest threat teams that I've seen are 3 or 4 people. Right? If they are spending most of their time trying to read through documents, then things are bound to fall through the crack. Again, relying on human memory to be able to detect or remember and correlate insights across several documents is another massive waste of time and energy and effort on behalf of these analysts. How many of you use spreadsheets to convert data from PDFs, text documents, blogs, and use that as a continual source or repository? No one? All right, well, that's good. It seems like the state of the art has moved on. But it is the status quo right now. We are still focused on using humans where they are not efficient. Or rather, they shouldn't be doing some of those things. So how do we use computing technology to move the dial towards that 80-20 rule, right? And as you look through this, and these are kind of insights that we came across as we spoke to teams that we support and as security researchers ourselves, is what can we do with threat data that, or at least the problems related to threat data that have been solved in other domains? Natural language processing was one of the first things that came to mind. Being able to automate the parsing, or even semi-automate the parsing of data into some kind of a output that is semi-structured. That itself gets you much closer to being able to use at least some semi-automated techniques for analysis of the data, being able to share that data, right? Don't want to still go to the process of picking up the phone or sending an email, which is again in some kind of an unstructured format, expecting the person on the receiving end to parse through it and understand what that format means. Right? So getting to a common understanding is something that we can get to using natural language processing techniques. So as we started talking to the natural language processing experts that we have within Accenture Technology Labs, it became clear that they have been working on addressing this problem in other domains. So we figured, how do we bring the security expertise, layer that with natural language processing, and try and at least address this problem to the point where we're not going to find the silver bullet here. That was never the intent. But even if we can increase the efficiency of human analysts by even 10%, I think we are taking a step in the right direction. So again, I'm not going to drain the slide. It's pretty simple overview of the framework that we are using to create this solution for a research project. But there are a couple of things that I do want to focus on. First one is the information extraction module. I'll be going through exactly why we picked a specific application within natural language processing, which is information extraction. The other is standardization. One of the objectives that we set out to achieve was converting this unstructured or semi-structured data into a common understanding or commonly understood format. Why sticks? Well, I'm not going to go into the justification and rationale behind sticks itself. It's a standardization effort. Is Sean Barnum here? No. He had a great talk last year about how standardization efforts help with sharing insights. The guys at MITRE are doing some really great work. So again, the notion was need to get to a standardized format, and we went with sticks. We also, instead of storing the data in just a traditional relational database, we decided to go with a graph database. And as you look at how threat data itself is represented, it is multidimensional, there are lots of relationships, and being able to maintain these relationships in a relational database, we found out very quickly was going to be a task not worth pursuing. Graph databases themselves lend themselves really well to representing this hyperdimensional relations between the data itself. So being able to quickly recall the degrees of separation between different data, between different thread data and the documents that they reside in, those were the kind of things that we wanted to represent and be able to do it quickly. And the third module that I really want to focus on is the learning part. As I mentioned at the start, this is a machine learning technique at the end of the day. There needs to be a way of continually sending feedback into the system. So we wanted to give the analysts, the experts, the ability to either say, yes, a certain pattern is good, or a certain pattern is not good. This is not a perfect system, so we want to use the effort that analysts are already putting into analyzing this data and help the system improve over time. NLP 101, just a quick primer. How many of you are familiar with natural language processing techniques or have done any kind of research on it, right? So there's a few of you here. The primary purpose is to replicate how humans process language and be able to replicate the linguistic analysis techniques. Several different applications of natural language processing. Natural language processing itself is kind of a catch-all term, right? But there are, within the field itself, there are several very specific applications and outputs that you get from these different applications. We focused on information extraction. And the idea behind information extraction is to be able to automate the task of identifying, collecting, and normalizing the relevant information into a structured output, right? So information extraction is more than just keywords. It's more than just string processing, although there are some of those elements involved in there. But we are not going to the point or to the extent of fully understanding the text the way humans have the capability of doing, right? So these applications are very domain specific. Information extraction works well if you can represent the human expertise within a specific domain the right way. So that was where a lot of our time and effort was spent. Grade school, anyone? Right? So this is just a quick review of the linguistic analysis that we go through. Humans do this really easily, very intuitively. Trying to have a machine do this is an extremely difficult challenge. It is not a trivial challenge. Right? So as we go through the increasing levels of analysis, we looked at doing morphological analysis, which is breaking the words or a complex word into its basic form. So if you take, for example, the sentence, the 3 buffer overflow vulnerabilities could allow remote code execution. Right? So when you look at the word overflow, break it down into over and flow. Try and get to the basic units. Understanding the syntax, so are the words correctly placed, and what kind of meaning are you getting out of it? And the third level of analysis, the semantic analysis itself, which is really understanding what does a word mean within the context of the sentence. So if you look at the word buffer, there are several meanings. There's a noun form, there's a verb form. Within the context of computation, it means a storage, right? It's storage. So being able to get to the right meaning of the word is extremely important. So as we started looking at and working with our natural language processing experts, these were the kind of things that we really focused on. So just a high-level summary of approach. Now here's where we really dive into the kind of framework that we set up for extracting the data, and also we'll talk about the different algorithms that we used for analyzing the data. So it was a 6-step process. The first step, just break the entire text into its sentences, right? So sentence segmentation. The second step, which was a core part of our work, was to generate patterns related to each of the STIX data constructs. So when you look at IOCs, TTPs, course of action, we generated base patterns that would be used for the analysis in later stages. Step 3 was stemming. This is, again, an NLP technique to reduce the complexity in the actual language itself. So stemming essentially boils or distills different forms of the word to its basic form. Think hacker, hackers, hacking. They all boil down to hack. So that's the idea behind stemming, reducing the complexity. Now, step 4 is where you take each sentence and calculate the similarity score by comparing the sentence against all the patterns that we had already generated in step 2. Right? So if you take a sentence, compare it against all the patterns in courses of action. Take a sentence, compare it against all the patterns within TTPs, IOCs, and so on. Once we went through that entire process, we'd find the best match in terms of the similarity score, the pattern set that was, or the patterns that were actually matched against that sentence with the highest score. And then we repeated steps 4 and 5 for each STIX data construct. So that was the basic idea behind this entire process. So for the pattern generation itself, this is a very crucial component of information extraction. Garbage in, garbage out. Very, very true for information extraction. So it was important that we started out with at least the right base patterns. We used a couple of different approaches for this. The first one was a supervised approach. Actually, Elvis, manually annotated the pattern list that needed to be learned. This is essentially a classification challenge. So you have a corpus of documents, manually annotate them, feed them through the classifier, and let the classifier learn. Right? So supervised approach. And then we also used a semi-supervised approach. This was used to boost the number of patterns, the base patterns that we could generate. The supervised approach is fairly tedious. It does require a lot of time and effort. So we wanted to boost the actual pattern list, and we used the semi-supervised approach. The idea here is you create a set of seed patterns, and you feed it documents that are not annotated. And because they're not annotated, this goes through a bootstrapping process where it keeps learning over time. There is human intervention required. If you just allow it to learn on its own, and if it keeps learning garbage, then you'll end up with garbage at the end. So that was another part of her effort, was to find the right kind of base patterns. Right, and let me quickly go to the next slide so Elvis can then really show you what this looks like in real life. So we went through several iterations of training and testing. We used documents and advisories from MSISAC, FSISAC, and ICS CERT. Ran it through the information extraction process, matched it against all the learned patterns that we had created, right? So the patterns that we created in the previous step, matched it against those, and we calculated 3 different similarity scores: lexical, semantic, and contextual similarity. Now, each of these have their own advantages and disadvantages, right? So the lexical similarity score works well when you're looking for co-occurring set of words. So think Siemens and semantic, or any other ICS domain product. There are a certain set of co-occurring words that you can identify. The semantic similarity score tried to detect a concept through a word or a phrase. And then the contextual similarity score analyzed a certain window of words around a known pattern to try and understand the context. As Elvis goes to the demo, he'll talk about why we generated the three different scores and how they were useful in being able to map to the right STIX construct. So aggregate the score, look at the result, and if the result's good, then make sure that the pattern is in the pattern list. If not, add it to it. If the score is bad, try and understand what went wrong, fine-tune the parameters. This is your traditional training and testing process that you use for machine learning. So enough slides. Just want to make sure that everyone's awake. Threat intelligence, any shmoo balls? No. All right. So, Elvis.
Can I drop the mic when I'm done? Hi, everyone. My name is Elvis Hovor. I have been with Accenture Technology Labs about 3 years. I started out of grad school. I lead some of the development work in threat intelligence down there. Okay, so let's start the demo, if I can find it. I don't have anything higher than 1440. That's the best I have. Anyway, is it showing any better now? Oh. What can I do? Help here. Reduce it. Zoom out. Okay. That didn't help. That good? Thank you. Okay. So I think like Shimon said, initially we started with trying to think about, how to help analysts really prioritize the advisories that they get on a daily basis. I'm sure that a bunch of analysts here, you get documents on the regular that you need to read through every morning, try and figure out which one to read first is a task on its own. Which one has the most important information or relevant information to you is also another task that you have to go through, wasting your time trying to figure out which document to read and all of that. Shimon went through a lot of that. What we wanted to do with our research project was initially started with just trying to prioritize these documents. But as time went on, we decided to wrap UI around that to make it easy and more usable for anyone that wanted to use a tool. So we moved away from just the research portion of it to try and put a UI on top of it. What you see here is, on a regular day, you come in and load up bulk documents, basically. It displays on this page, and it shows you scores on which one we think is, or you have prioritized the most. Once again, this is a research idea. We gave it scores because we thought that those were a good way to score the documents that we have. But based on your own preferences, you can score it differently and it will show differently. But you look here and then you see a set of documents, and these are the ones that are prioritized for you to read first and second and third. It came in on different days. We have a set of data that spans maybe 3 days. We wish we had more, but it spans about 3 or 4 days. That's about how much we have. I would try and go through the process with you, loading up how we are calculating the scores and what kind of information we are getting out of it, the data elements we are able to extract out of each document, what extraction method works better for us, and what we realized would work to extract certain sticks elements or constructs better than other ones. And so as I go through, I'll explain that more. So I'll come here and upload the data. First, I would upload a file that has, I guess, the patterns were trained or according to that file structure. So it extracts a lot better if you trained your pattern set against a specific document and have trained your modules over time to be able to extract that data more. So you would see that one works very well and the other works somewhat okay. So let me try and upload. Okay, this is a file I can upload. Choose. Oh, and we were trying to. Goodness, what's everything? We're trying to make it a batch file because it takes, sometimes it takes just a little bit of time to run a single file. So we're thinking if someone has multiple files that they want to run, you want to be able to make sure that you can make it a batch job for the first one to process and the second one to come in. But for some reason, Java won't allow, or we haven't figured out how to have Java, the computer run the Java command on its own, because it's kind of like sandbox and won't allow us unless we enter the command. So I have to enter it here, but that gives you an opportunity to see what's going on in the background, how the, how it's comparing to the patterns like Shimon showed earlier on. So that's the extraction that's going on right now. So if I get back to my page here and I go to my prioritized list, at the end of the list table, you should be able to see the file that we just entered. This sucks. My bad, sorry. It shorted out a little bit, but what eventually happens is that when you run it through and the natural language processing module is running in the back end, it should tell you that it's being processed. And when it's done, when you refresh your page, you would see it shows an output that says that it's been processed, and so you can go ahead and start looking at the file. So if you have a bunch of files, this is going to be a batch process that keeps going through and taking the files through. I have to shift this a little bit just so I can get to that. So that's it. The file is uploaded. It's running right now. I'm sure it's done. If I highlight it, it should move. Please pay attention to the file name. I think it's USCIC cert. Okay, here. All right, thank you. Yep. So now that means that it found enough information in there to think and score it to take it to the third in your stack of documents that you have. I'll tell you a little bit about the scoring as we go through and why the scoring is that way. It's not perfect yet, but as time goes on, I think we will tweak the scoring a lot more to get some of the information that we want out of it. So the document will show on the right-hand side, and the elements extracted would be on the right-hand side. So you see your COAs, all the things that it was able to extract out of the document, you would see from here. So for COAs, we can see that they extracted a bunch of things out. The score you see here is 1.0. 1.0 because anything that comes out of contextual similarity extraction, if we use that method, gives us a binary number. It's either 0 or 1. It was able to extract something, it wasn't. Semantic and lexical are a little more different in that the scores actually work, and you can tweak them very well. So that is one part that kind of skews our score a little bit. But what ends up happening is that if you still don't find anything for, or if you find contextual, which is 1, we decided to average it out for a document. So if lexical and semantic similarity methods didn't find anything, you would still average it out by 3, and it ends up reducing the value of the score. So we were able to find some COAs. It gets, because of the patterns that we have, sometimes it can extract certain information that is not necessarily accurate, or extracts before it's supposed to extract the full sentence. Because of this, we wanted to build in, like Shimon said earlier on, a learning module to make sure that we are correcting this automatically, or the module in the back end is learning to update itself and delete the patterns that don't work and all of that. So we put the Facebook style thumbs down there just to delete anything that we believe is wrong. So now it's taking all of the how-tos out because it was extracting how-tos. And what we built inside that again is the ability to delete this pattern, whatever pattern is pulling out the how-to, if it reaches a certain threshold, if it gets a certain number of thumbs down. So that way the module is learning. And as time goes on, we want to be able to build functionality for the analyst to be able to, highlight a text or highlight a pattern that he thinks the natural language processing module is missing, and then it's going to add on to a set of the documents that we have. You can see here there are TTPs, there are IOCs in here, and they pick up pretty good ones if the document is really known and the patterns were tested with that document. I would go in and pick a regular document from CERT and upload that and see what the difference is. You would see that some of them would not be as great as what we have with the documents that have been tested already. So what, first one? Come on. Goodness. Okay, .txt. Upload it again. Let me run my command file one more time. Once again, we should be able to see it being processed. And when we highlight it, when it's done, we should be able to get into the file and check that out. So whilst that is running, these are some of the things that, these are some of the findings that we saw as the research project went on. We're hoping that we could use one of the similarity methods, the lexical, contextual, or semantic similarity methods to extract the information that we needed, but we realized that each one has its own advantage. So it would not be wise for us to end up to just choose one and leave the others, because we saw that maybe for contextual similarity, it was able to pull things like threat actors, the things that have very specific elements that need to be pulled out, like a word or a very small phrase, a phrase that isn't too long. And then for things like TTPs that sometimes can span multiple lines, we saw that using things like semantic or lexical similarity methods will pull those out better for us. So we ended up using an aggregate of all of these three to be able to get this, the information that we needed. So I believe it is done, and we can check that out. Nice. Ah, that's it.
It's a work in progress.
Right. So out of this document, it was able to pull a bunch of exploit targets for us. As you can see, it grabs, sometimes it can grab the sentence that you want and not necessarily give you the element that you want. It might grab it before, it might grab it after. It's just, I guess, the patterns and then having to get the right pattern match for each document. The thing with natural language processing, and I think it's natural language processing as a whole, it's still being developed to get to that fine-grained point where it can pull very specific information. And so as much as we were trying to get it, and this is also, I guess, a project that we are still building on and trying to get to the next step, we do have a few things that need to be tweaked here and there, but it is extracting some information. So if you, as an analyst, can get to move away from doing all of these things and, having just a document moving up and telling you that I have this amount of information on there that is related to threat information, and I think you should look at that and see if that applies to you. It's going to make your job a little more easier. So after we were done with putting this information in a more structured format, which is the sticks that we have here, and I think there's a caveat to putting it in a structured format in sticks, and I'll put that in our challenges at the end. But we wanted to do the higher order analysis that I think Shimon spoke about early on. I mean, if we have the information in a more structured format, there's so much we can do with it. So we decided to take some examples and do some D3 visualizations on top of that, of the data that we have, to see what we can pull out and what we can do with it. Like we said, it's just examples. It's, we had a graph database. We're pulling out the information out and trying to see what we could relate together and the kind of information that we can pull out of it now that it's more structured. So we decided to use this tree map. This is one of the first ones that we have. To show the information that we have in there. And thanks to Sean, our D3 guy, he helped us a lot on this. So we decided that, if we could use a tree map to see what information is contained in the documents, then you can have a general idea. If you limit the documents that you have to maybe a 1 week set of documents, and then you want to see what has shown up a lot in your advisories that you've collected, maybe, and I think one thing that I've forgotten to say is that, I mean, as analysts, or as the threat data team or the threat analyst team, you collect documents that are usually related to your organization. So some of this information can get very specific to your organization because you're collecting data that's around your the kind of operations that you guys run in your organizations. So here you can come here and just look for maybe threat actors and see in the last week which threat actors have shown up a lot in the documents that I have, or in the last day, maybe last month. Which one is coming up a lot, and why should I be worried about that? And then you can do the same for COAs. Go into your COAs and see what kind of COAs are out there. As you can see, the COAs are the word sentences or very long sentences. Trying to display that in D3 was a little bit of a hassle too. We're still trying to figure that out, like we said. So we want to be able to give the user the ability to be able to see what the whole COA is. When I say COA here, I mean causes of action. I'm sorry. I'm using a lot of acronyms, am I not? Anyway. The other visualization we decided to use was historical analysis. Here, we wanted to either give the analyst the ability to widen the net or tighten the net some more. You have documents, and I think one of the problems that we're talking about earlier on is that as an analyst, or as a human trying to analyze these documents, you may have seen some element in there, maybe a threat actor or a TTP that you were concerned about, but it was way back, let's say 4 weeks back or a month back, and you don't remember which document it was anymore. You never did anything about it, but all of a sudden you see that picking up again, and you want to be able to find those documents that are related to that document that you just saw, but there's no way you can remember it. You don't even know sometimes if you ever came across that. We wanted to show that information here and make sure that we give you like a historical view of the kind of documents that you have in your repository or in your database. So what you see here is a list of the documents that we have in here. It's a limited list that we have, and then anytime you mouse over a document, let's say you just put a new document in, it shows up. Anytime you mouse over it, you see the documents that have been that are connected to that document in any way. So if it's a set of threat actors that are connected, it's going to show you a different color. If it's a set of IOCs that are connected, it's going to show you a different color. It just gives you an idea of how your documents are connected together and which ones you should be paying attention to if you ever want to go back and read or look at some of the information that you have in there. Like we said, this is all it's it's all going into our Neo4j database. So Neo4j has a front-end query. You can go in there and query the data that you want and do it whichever way you want. This is D3. It's all open source. You can decide to use whichever visualization you want to use on top of this data to pull whatever you feel is most necessary for you. These were just examples we wanted to show. Yep. And so some of the challenges that I guess we had going into this, and we realized were going to be a hindrance for us is that, sticks. We wanted to put it in sticks. We said sticks. We want to make sure that everything is in sticks. It's more structured, but sticks is very expansive, and the data or the elements that you need to extract into sticks can get very, very, very granular, and you need to make sure that you capture that out of a sentence, or you capture that without missing the meaning of that in the sentence. And it became very difficult. We tried with natural language techniques to get granular, and we saw that we were missing a lot of information that we needed. So we decided to expand it a little more and go for the broader sticks constructs, which is IOCs and IOCs, threat actors, things of that sort. It's broader. That way we can capture a lot more. We might have to capture it in a sentence instead of capturing the element, but it still gives you a better idea of what's in there. And as time goes on, and as this is developed, and as people, put a lot more effort into it, we believe that it's going to get to that point where the natural language processing engine will be able to go directly and look for things like affected systems and just pull that affected system out and put it in a very, very specific place that a machine can easily use. Do you have anything? Okay. Yeah, so that was one of it. And also, I think this is one of the most basic NLP problems around. Having one word that means something else in a different sentence. So it's difficult. As humans, we are easily able to kind of make those out. But for a computer, it's a lot more difficult for the computer to make out that, maybe, what? Give me an example. Maybe attacker, right? In one sentence means that that's the person that actually committed a crime. It's a threat actor, or and its simple form, attack's simple form is actually attack, right? And for the computer, it sees it. It tries to break it down into all of its simplest forms for natural language processing, and all of a sudden that attack just means it's trying to explain something else in the middle of a sentence somewhere in TTP. It ends up pulling that same attack, just like it's trying to pull attacker. So things like that made it very difficult. These are underlying NLP problems, and I think that as we go forward and we put a little more effort into it as a community, it's going to improve, and this is going to help in some of the work that we're trying to do.
How much time do we have? All right, let me just take it home. So yeah, in terms of what are we trying to do moving forward, right? Like we talked a little bit about some of the challenges that we face, some of the results that work, some of the patterns that work. One of the first things that we want to do is extend the functionality of tagging new patterns from the screen itself, right? So that's really put the power of the tool in the hands of the analyst. There's a lot of fine-tuning to be done with the weighting parameters. As we go forward, one of the things that we found when we were doing the analysis, threat actors, and I was talking about this, threat actors, TTPs, were getting really accurate results using contextual similarity. But then there are highly specific elements within indicators of compromise, within observables, that are better suited for lexical and semantic analysis. So we are looking at those components as we go through the iterative process of making this solution and the underlying engine better. Expand the pattern sets for different types of documents. Right now, we are heavily focused on US CERT, ICS CERT, and MS ISAC. Those documents tend to have a lot more vulnerability, courses of action. Sometimes they might have threat actor and campaign names. Unusual. So we want to expand the actual corpus to include that spectrum of information. And one of the next things that the natural language processing team is really going to focus on is being able to incorporate named entity recognition, right? So being able to identify references to known names and entities in the text themselves. This can be really useful if people do follow a common standard of naming campaigns and threat actors. These can be used for named entity recognition techniques. So, right, like everything that we've used here is based off open source technology. And if you do want to tinker, and I believe quite a lot of you here are hobbyists, right? If you want to build your own stack, where do you go about putting this together? There aren't a lot of NLP people here. We had to go about trying to rely on the knowledge of our team to really understand how do you put this whole stack together. So Apache OpenNLP, definitely look that up. Excellent resource of both implemented algorithms and documentation. They have all the underlying technologies that you need for parsing the sentences, applying stemming, doing any kind of part-of-speech tagging, any kind of basic parsing. Right? They have a lot of great implemented algorithms already out there. The Stanford Natural Language Processing Group, again, a great wealth of information over there. They also have released a lot of their algorithms on their website. And WordNet, it's essentially a lexical database of English, right? So whenever you're trying to do similarity scores between words that could have the same meaning or could be related, WordNet is the world's largest lexical database. So definitely, that's a core component of what we are using. And then the text rank algorithm, again, this is a core part of how we are doing the lexical similarity matching, or how we intend on implementing lexical similarity matching. All of this is open source. It's available out there for you to go download. And one of the things that we want to do over in the near future is we'll be setting up, we're looking to set up a GitHub repository and at least start a flow of information of our learnings into the open community. So yeah, with that, I think we still have a few minutes for questions. I'm sure you guys have a few, and thanks for your time. And if you do want to follow us, you can follow me on Twitter. Hit me up with any questions. If you want to take anything offline, we'll be happy to start a conversation. So, but with that, with whatever little time that we have left, we'll be happy to take any questions. Thank you.